Good day, everyone.
I'm Teacher Rona.
I'm Teacher Hannah.
We're going to discuss the multiplication
And division of polynomials.
Multiplying polynomial. Before we proceed in our lesson, let's define first what polynomial is. Polynomial is a general term for a mathematical expression. It means it can be one or more terms. It consists of coefficients, numerical and literal coefficients, and exponents. Constant considered as polynomial. I guess you know how to identify if it's polynomial or not. After you learn how to add and subtract polynomials, let's proceed in multiplying polynomials. Here are the steps in multiplying polynomials. First, distribute each term of the first polynomial to every term of the second polynomial. Remember, in multiplying polynomials, you must multiply the numerical coefficient or the number, next the literal coefficient or the variables, then add the exponents. Lastly, if needed, simplify the answer by combining like terms. Let us look first at the sample cases in multiplying polynomials. Example number 1. Simplify 3 times 2x. Before jumping in multiplying, let's break it down one by one. So, 3 times 2 times x. You can get rid of the parentheses and write it out like that. Avoid using x to mean multiplication. It can get confusing with the letter x as a variable. Use dots for multiplication. After you break down one by one, you can now multiply it. Follow the steps in multiplying polynomials. So, 3 times 2 times x. 3 times 2 is 6 times x is 6x. 3 times 2x is equal to 6x. Example number 2. Simplify 3x times the quantity of 4x plus 2y. In that example, you just need to distribute the first polynomial in each term of the second polynomial. Then add the exponent with the same variable. Step 1. Multiply 3x to 4x. So, 3x times 4x is equal to 12x squared. Step 2. Since it is positive in the parentheses, add it to the product of 3x and 2y. Step 3. Multiply 3x to 2y. So, 3x times 2y is equal to 6xy. Combine your answer. So, 3x multiplied to the quantity of 4x plus 2y is equal to 12x squared plus 6xy. Since there is no similar terms, there is no need to simplify it. Third example. Simplify quantity of x plus 2 times quantity of x plus 1. In this case, you can use FOIL method or stands for first, outers, inners, and lasts. First step. Multiply the two first terms in each polynomial. Second step. Multiply the outers of the polynomials or the first term in the first polynomial and second term in second polynomial. Third step. Multiply the two inner terms in each polynomial. Last step. Multiply the two last terms in each polynomial. Combine all your answers on the steps that you did. So, x squared plus x plus 2x plus 2. Since there is a similar term in the answer, combine that term. X plus 2x is equal to 3x. The final answer is quantity of x plus 2 times x plus 1 is equal to x squared plus 3x plus 2. Another example, simplify quantity of x squared plus 5 times quantity of x squared minus 10x plus 6. You just have to distribute each term of the first polynomial in every term of the second polynomial. X squared times x squared is equal to x to the 4th power. X squared times negative 10x is equal to negative 10x cubed. X squared times 6 is equal to 6x squared. 5 times x squared is equal to 5x squared. 5 times negative 10x is equal to negative 50x. 5 times 6 is equal to 30. Combine all the answers and look for the similar terms and simplify. The final answer is quantity of x squared plus 5 times quantity of x squared minus 10x plus 6 is equal to x to the 4th power minus 10x cubed plus 11x squared minus 50x plus 30.
Division of polynomials. There are two cases for dividing polynomials. Either the division is really just a simplification and you're just reducing a fraction, or you need to do long polynomial division. So, let's start with reduction of a fraction. For example, 2x plus 4 divided by 2. This division is just a simplification problem because there is only one term in the polynomial that dividing by, and there are two ways to solve this. First, split the division into two fractions. Then, simplify each fractions. So, the answer is x plus 2. Second, I will factor out the common factor from the top and bottom. Then, cancel off this common factor. It will become x plus 2. But take note, don't try to cancel before factorization. This cannot work. Fractions have understood parentheses around their numerators or denominators. Let's proceed to the long polynomials division. You will use this method if you are dividing a polynomial by something more complicated than just a simple monomial, and it works just like the long numerical division you did back in elementary school, except that now you're dividing with variables. For example, divide x squared minus 9x minus 10 by x plus 1. First, let's set up the division, putting the dividend inside and the divisor outside and to the left. Then, let's look at the leading term of the divisor, which is x, and then the leading term of the dividend, which is x squared. So, if I divide the leading x squared inside by the leading x in front, what would I get? I'd get an x. So, I'll put an x on top of the division symbol right above the x squared. Now, I'll take that x on top and I'll multiply it through the divisor, which is x plus 1. First, I'll multiply the x on top by the x on the side, then carry the resulting x squared underneath, putting it directly below the x squared from the dividend. Next, multiply the x on top by the 1 on the side, and carry the 1x underneath, putting it directly below the negative 9x in the dividend. Let's proceed to the subtraction of the polynomials. To subtract the polynomials, first, change all the signs in the second line. So, let's add now. The first term, which is the x squared, will cancel out, while negative 9x minus 1x become negative 10x. Next, we need to remember to carry down that last term, which is negative 10 from the dividend. Then, let's look at the leading term of the divisor, which is x, and the new leading term of the dividend, which is negative 10x. And if I divide the negative 10x by the x, I would end up with a negative 10, so I'll put that on top right above the negative 9x. Now, let's multiply the negative 10 on top by dividing x on the side. What would I get? I'd get a negative 10x. And let's multiply also the negative 10 on top by the 1 on the side. I'd get negative 10. So, let's carry also the negative 10 to the bottom directly below the previous line's negative 10. Now, let's proceed to the subtraction of polynomials. So, the result is 0. And the final answer will be x minus 10.